sometimes when we're working with large or small numbers, such as, say, the diameter of the sun, which is 1,392,000,000 meters, or with really small numbers like 0.00000000000000016 meters, the diameter of a typical nucleus. When dealing with really large or small numbers like this, it's often really awkward to have to write 0 so many times. And so to deal with this problem, to make it so that these numbers are more manageable and the calculations with them are more manageable as well, oftentimes we want to use scientific notation, in which we take one digit, some number, and then we have a decimal to the right of it, and then we can have other digits as well. And then we multiply by 10 to the some whole number, either a positive or negative number. Okay. And so how would you scientifically notate the following numbers? Say you wanted to scientifically notate 4,943. Well, to scientifically notate this number, what you need to do is realize that there is an imaginary decimal here. And so you need to move the decimal so that there's only one digit to the left of the decimal. So you need to move the decimal 1, 2, 3 times, so that you get 4.943. Now, when you move the decimal, however, you're going to change the times 10 to the exponent. Now, initially, this 4,943, it had a 10 to the 0 multiplying it. You can agree with this when you agree that 10 to the 0 is 1. 4,943 times 1 is the same as 4,943. So initially there was a 4,943 times 10 to the 0. But when we move the decimal, that changes the exponent. You can describe how the exponent changes by seeing this staircase. Now, we start with, say, 10 to the 0, and if we move the decimal to the left, then that 10 to the 0 becomes a 10 to the 1. And if we move it to the left again, it becomes a 10 to the 2, and then a 10 to the 3, and a 10 to the 4, etc. And if we go down, if we move the decimal to the right, then the exponent falls. Now, in this case, we move the decimal 3 times to the left, and so you see it hops over 3 times to the left, i.e. 3 times also up. And so we change that 10 to the 0 into a 10 to the 3. So what if you needed to scientifically notate this number, 0.0014? Well, again, you need to move your decimal. This time, you need to move it so that it's just to the right of one non-zero number. And so we need to move that decimal once, twice, 3 times to the right. And so moving that decimal 3 times to the right, where initially we had a 10 to the 0, we're going to move from 10 to the 0 to -1, -2, and -3. So that the new value is 1.4 times 10 to the -3. Note that there are 2 zeros to the right of the decimal before our numbers, and there is a -3 as our exponent after scientific notation. You should always have, let's see, 1 less 0 than the negative exponent. Now, what if you need to undo scientific notation? What if I gave you a number? It was 2.364 times 10 to the 4. Having this number, you need to get this out of scientific notation sometimes. And so to do that, you need to convert that 10 to the 4 into a 10 to the 0. And to convert a 10 to the 4 to 10 to the 0, you need to move that decimal to the right. So you need to move that decimal 1, 2, 3, 4 times to the right. So you move it once, twice, 3, there's imaginary zeros here, 4 times to the right. And so taking this number into just normal non-scientific form, it's 23640. Now what if you needed to take a number such as 0.0043 and get that, actually, my bad, 4.3 times 10 to the minus 3, and you wanted to get that into normal form. Well, then you would need to move that decimal again, the decimal again, to get that 10 to the minus 3 into 10 to the 0 form. And so you move the decimal 1, 2, 3 times to the left. And so there are imaginary zeros here. Move it 3 times to the left. 1, 2, 3. And so we get 0.0043. All times 10 to the 0, aka 1. AKA, you don't need to consider any of that now. Note that because we have a 10 to the minus 3, that there will be 1 less than that, 2 zeros to the right of our decimal before we start writing non-zeros. All right, thanks for watching, guys.